Hi guys, this is Deepak. Thank you for joining with us today. Today we are going to discuss about OpenStack. This is OpenStack beginner guide actually. So if you this course had some prerequisite requirement. So I expect that you know Linux. If you are very new to Linux, I would suggest you to go back and check some check some basics. I was planning to start with Linux actually, but I found very good videos on YouTube, so I'm directly touching OpenStack today. Let's start with the agenda. We'll start with traditional architecture and related problems. We will understand what is cloud, and then we'll go and see service model offered by cloud computing. Then we will understand deployment of the cloud, how we can install cloud, or what are the various options of deployment. After that, we'll go and check cloud components. Finally, we will see Trystack for practicing OpenStack without even installing it. Let's go back to the old days. We used to have a big server designed for peak load, which could be only for a day or two, like Christmas. So in this resource utilization report, you can see that the server was busy during only, let's say, June month, and other months it was literally idle. So this is where we lose a lot of our capital as an organization. So we own the infrastructure throughout the year, and it was underutilized. It was literally idle. To answer this type of questions, or to mitigate this type of wastage, they introduced something called virtual architecture. So let's compare traditional architecture and virtual architecture. So in traditional architecture, we used to have server, a big giant server designed to handle peak load. On the top of it, very tightly coupled operating system. Most of the time, it used to come with the server, and then application hosted on it, which was designed for this type of static architectural design. Versus virtual architecture, you have your server maybe with similar spec or commodity hardware even, and you have your hypervisor installed on it. Now you will see this is new layer here. What is hypervisor? Hypervisor is actually a program which talks to your hardware and dynamically assign your hardware to operating system in real time. So this hypervisor which will create a virtual pool out of this hardware, and then it can literally host multiple operating systems in isolated fashion. So this operating system will never know that there is another operating system running on the same hardware. And then on the top of this operating system, you have your application, and this is designed for virtual architecture. So when you have your peak load coming, for example, you know that tomorrow you need more resources to cope up with the load. You are expecting huge traffic. You can shut down this operating system for some time and expand this operating system to consume this whole hardware and serve this huge traffic. Once again you are back to the normal load, you can simply resize the operating system, the first one, and you can spin up or spawn other VMs on it, other virtual machine I mean. So it was very flexible. So before moving ahead, I would like to mention, as we see hypervisor, new word here, there are two types of hypervisor. Hypervisor type 1, which is native. This is very tightly coupled with hardware. This hypervisor, type 1 hypervisor, will actually runs on the hardware directly, like Zen, VMware. There is another hypervisor called type 2, which runs on host OS. So you have your hardware, you have operating system like Linux, and you have hypervisor like KVM or VirtualBox running on the operating system, and on the top of this hypervisor, then you can create your own virtual machines. in OpenStack, we are gonna use KVM most of the time. Though we can directly use VMware and Xen, we have these options. Now let's go and define cloud computing in layman language. So for me, when we use a lot of application on mobile like Google Docs, Google Spreadsheets. We use many applications like we use Facebook. We upload videos. We download something. We use many applications from Android store, and we wonder where all this data is going. How simply they can take a backup of my phone, and even if I have new phone and configure my account, I can see everything again back simply. This is the beauty of cloud. So cloud is internet based service. To use cloud, you need to be connected to the internet. Somewhere in the world they have bare metal server and virtual infrastructure installed on it. It exports something called application programming interface, and your application installed on your device will use this API to access services facilitated by cloud. For example, in Google, let's say if I am using Google Drive, I am actually accessing data storage from the cloud. So the definition from National Institute of Standards and Technology says, cloud computing is a model of providing widely accessible and convenient access via network to common set of adjustable computational resources. This is what it is. So our device connected to the internet, and this is the cloud exposing API, or application is talking to this API and utilizing cloud services. So now I believe this is very clear. Let's go ahead and understand what are the service models offered by cloud. So we have three service models offered by cloud. One is infrastructure as a service, platform as a service, and software as a service. When we say infrastructure as a service, we can see that as an administrator of the cloud, we are going to offer infrastructure only, meaning we will offer virtual machines, we will offer network, we will offer other infrastructure related services. From developer or from user perspective, we will have to take care of programming environment, application and application setting. So full stack of, you can say, operating system up to the application level. So we will give them, okay, this is the infrastructure, and now you can build your own virtual machine on it. You can install the application on it. You can take care of the virtual machine as per your requirement. You can configure it as per your requirement. Right? This is where we are saying this is the infrastructure as a service. So customer have control over all level of software stack above cloud platform. So what we are gonna present to them is a cloud platform, and this is where they can spawn their VMs, and they can create their network, they can create their volume, they can create their storage, and they can attach it to VMs, they can configure anything, literally a virtual data center actually. What's the popular example of this service, infrastructure as a service? Amazon EC2 is most popular. Even OpenStack lies in this model. Next, platform as a service. So this is where we are gonna offer platform to our customer. For example, we own the hypervisor, we own bare metal hypervisor, operating system, the cloud platform, and on top of it we have something called programming environment or a platform where developer can come and simply start building their application. For example, OpenShift, they are providing containers, containerized services, container services actually, so that application owner will simply come and they will start writing their code. So customer gets control on the level of platform application build. For example, application server, libraries, programming environment, and databases. So now you can see that the application owner have less control on the infrastructure side, so that it's actually positive thing. So that he can concentrate on application area most of the time. So he don't need to take care of any underlying say infrastructure. Platform as a service, software as a service. This is where we are gonna own the full stack, kind of. So we have our cloud platform, we have programming environment, and application itself will be hosted on the cloud. User will only have application configuration control. For example, you are using Google Docs. What you can see is only application. You can configure it, you can install it on your laptop, mobile, you can configure it, username, password, and many other settings like what to download, what not to download, what to sync, what not to sync. You do not know what is underlying infrastructure. Is it virtual machine? What's the operating system installed? You can't. So this is kind of abstraction which gives you simplicity. So you don't need to worry about underlying infrastructure. You just need to use the application, and cloud platform owner or the organization who owns the cloud or software as a service, they will charge you back or as per your users. So now we understand all three service models offered by cloud computing. Let's go and see the deployment model of the cloud now. Let's see deployment model of the cloud. We have 4 types of deployment models: public, private, community, and hybrid. So in public deployment model, you have giant organization like Amazon, and they have their cloud as public cloud offering. So as even one person can go and register the virtual machine, or even organization can go there and ask for the virtual data center. Definition is very clear here. When we say public, meaning some giant organization will own this cloud and they will publicly sell the services to anybody. So even you, as a single person, you can go and buy virtual machine, or an organization can go and buy the virtual machine. Let's say we have one organization, small organization, but we have some limitation. We cannot put our data in the public cloud because of some legal restrictions. We have only one available option, that is to own our own cloud. So they will let's say they will install their own cloud and manage it, and this cloud will only serve internal customers, right? They are not providing any services to outside users. So the cloud designed, deployed, and managed by single organization for their internal customer, called private cloud deployment. Now what is community-based cloud deployment? Let's say we have 2 organizations in same sector. They have similar requirements, similar tasks. Instead of owning separate cloud, they can come together mutually. They can understand, have some kind of MOU, and they can build their own cloud together. This cloud will serve only these 2 organizations. And third one is hybrid. Now what is hybrid? Meaning in this model you will use multiple, for example, you will use multiple deployment methods here. So what's the use case? Let's say we have this organization and we have some sensitive data which we cannot put on the public cloud. So they are saying the production data can't go on public cloud. We have some restrictions. Fine. They will build their own private cloud for production deployment. Now there is some guy like me. He is saying, okay, why not to test your application in public cloud at least? So okay, they agree and they employ, or they go and buy something from public cloud provider to test their application before going to production. So now they don't have any sensitive data in public, but they are testing their application outside their data center, meaning they don't have any ownership of it, and they can save money. Lot of money actually. This is where hybrid deployment model comes in the picture. So if you have any question on any part of this presentation, please don't forget to comment on this video. If you like this video, definitely go and subscribe the channel so that you will not miss any future videos. So component that make up the cloud. So what are the component that makes up the cloud? We will start with Nova. We have Nova, and this is the actual server. This is where we are gonna spin up instances. So now, before understanding this, you will have to understand full data center now. You can simply say that we are virtualizing the whole data center. Yes, you are. So this is the compute project. This is gonna, control your server where you will run your workload, actual workload. Now, any servers, you need storage. So you have Cinder. This will provide you block storage. You have Glance, which is like image storage. So remember, we used to have something called central NFS server, and this is where we used to dump our all images and backup so that we can use these images for pixie booting and installing new services. This is the similar service virtualized called Glance. This is image storage. We have something called object storage. Similar to block storage, the object storage is like ID based. So you have one image, you will put it on object storage, you will get one ID for this particular image. You can always go back and say, okay, this is the ID of this, and this storage will return you that image actually. The storage can be accessed with multiple protocols. We'll go and check each and every module of this. This is just an introduction, so I'm just moving fast. Every server would need networking actually. So we have something called Neutron, which takes care of networking of the virtualized environment. What is Keystone? Keystone is nothing but identity engine. So you have, for example, AD. Let's say in this kind of AD, you can say. So all these modules have services associated with them, and these services need to be authenticated before any action or before any process, I would say. Not only these services, users from outside, tenants. When I say tenants, meaning project. For example, you have some department, you are saying, okay, a finance tenant. So finance tenant, for example, if they are coming here for some services, they'll have to authenticate themselves. Keystone will do that, the authentication engine. Heat. Now, this is orchestration. Now, why you need orchestration? As I mentioned, whenever you have peak load, you can simply resize the virtual machine. Heat can take care of this. So if you have peak load, it can resize the virtual machine, or it can spawn up another virtual machine on the cloud platform to serve the peak load. We are gonna deep dive into each and every module. For now, this is just an introduction. What is telemetry? Yes, you're right. As name says, it's a metering system. This metering system will always keep eyes on you, and it will meter everything, each and every utilization of any services from cloud. And this is the model you can plug into your OSS, BSS, or your billing system to bill your customers. What is dashboard? Dashboard is actually the GUI for managing the cloud. So this was the short introduction on the cloud component. Let's go and very briefly each module. So we have Nova. Nova is this allows you to control infrastructure as a service cloud computing platform. So this is the module which will sit on the actual server where you will run your let's say run your application. So this is the module responsible for managing virtual machine on your servers. OpenStack networking, as it says, this is a networking module. This will manage networking of your virtual infrastructure. OpenStack identity service. As I mentioned, this is identity engine. Any service or any request should be authenticated or shall be authenticated by Keystone before any action or before getting any kind of service. Any user or service requesting some resources from cloud should be authenticated by Keystone. Otherwise, it will be denied, it will be rejected. OpenStack image service is nothing but image storage. This is where you will store your images, for example, CentOS, Red Hat, Linux operating system, or any other OS, which you can then use to launch or to spawn any virtual machine you need. Glance can be used for storing backup like snapshot of the running virtual machines. It supports a lot of formats including VHD, VMDK, VDI, ISO, QCOW2 and AMI. OpenStack object storage. Now, as I mentioned, OpenStack object storage, this will allow you to store files and it will give you some kind of ID. You can always go back, or any program can always go back and refer to this ID. It will provide you the the particular object in return. So Swift is actually oriented mostly to static data such as virtual machine copies, backup copies and archives. So if you want to store something for longer time, it is always advisable to go on Swift. This is distributed platform, so you don't need to worry about your data. It's secure. This will not be hosted on single machine. This will span on multiple hardware. Even if you lose one hardware, it's not going to impact your data. Telemetry, as I mentioned, this is kind of watcher. It will record each and every uses per user, per process, and it will then this information can be utilized by billing system to charge you back. Orchestration, as I mentioned, orchestration can be used to literally build the virtual data center. It can be used to launch multiple virtual machine networks, and literally it can create a kind of automated infrastructure launching experience. So you can use something called HOT, heat orchestration template, to automate your infrastructure deployment, even decommissioning. This is OpenStack dashboard, Horizon. This is, you can say, and this is the last module, I would say, OpenStack dashboard, Horizon. This is the awesome GUI accessible via web browser. You can use it to perform almost 95% tasks on the cloud. Let me show you. Now we can see we have instances 3. This will show you the quota actually, and quota, your cloud admin can set the quota. I can spawn up to 3 instances, 3 virtual machine. We have CPU up to 6. I can utilize RAM up to 8 gig, floating IP 1. I have 1 floating IP, security group. I can use up to 10. Volume, data volume. This is Cinder backed volume. I can use 6. Storage, volume storage, I can create 60 actually. So let's go and try to launch something. So just to show you how you can work in Horizon, I am launching some instance, some virtual machine. Now I am saying to, let's say, boot from image. I am selecting image from my Glance store, Cirrus, because Cirrus image is for testing. It's very small, 12 something MB. I'm selecting access and security group. I'm gonna explain each and every tab in future videos. For now, if you don't know these tabs, don't worry about it. It's gonna come. Let's wait. It should launch our virtual machine. Okay, it is spawning our virtual machine 25.1, 25.2. Very soon we should see IP address popping up here. Okay, so we have IP address starting with 192.168.1.5 and 1.6, and this is where I have created the network before actually showing it to you. So I have actually created this one. So now I can see one network and 2 virtual machine connected to it, and both are active. So meaning this virtual machine can talk to each other in some same kind of subnet. So this is very good dashboard for managing cloud. Okay, as I promised, let me take you to the last point, which is actually using Trystack for practicing. So guys, I understand you guys don't have the OpenStack installed yet. I didn't show how to do it. I would say, rather than doing it now. I would say we'll do it together in next upcoming videos. For now, you can simply go and type this address in your browser. This is x86 Trystack, or better to go in Google and try Trystack, and it should give you the link for trying. Simple login to OpenStack dashboard. Click on the OpenStack dashboard. This is horizon actually, and you can see that you don't need to create username here. You have username. You can simply log in with your Facebook account. So you can click on it. I have my Facebook credentials saved here, so it may not ask me about it actually. Okay, timeout. Let me see what's the issue with this. Okay, this is how I can see that we have some instances running here, 2512. These virtual machines are running, and this is how you can use it. And you can pretty do anything here actually. You have enough resources available. You can practice your OpenStack initially, at least until we have our own. So now I am trying to access the console of one virtual machine just to show you. Here you go. We have access to the console. Okay guys, this is it, I believe, for today. So again, thank you for joining today with me, and we will continue our OpenStack journey together. If you like this video, don't forget to click on subscription button. Thank you.